Horizontal scaling in distributed systems with OSA and SageMaker. Definition: the method of increasing the number of nodes or instances in a distributed system to handle larger workloads and improve performance for large language models (LLM) and retrieval augmented generation. RAG projects. Leveraging AWS, Amazon Web Services and SageMaker. Key components: AWS Services, SageMaker, fully managed service for building, training, and deploying machine learning models at scale, supporting horizontal scaling for distributed workloads. ECS/EKS, Elastic Container Service (ECS) or Elastic Kubernetes Service (EKS) for managing and orchestrating distributed computing tasks across scalable clusters. Auto-scaling groups, AWS feature for automatically adjusting the number of EC2 instances in response to changing demand. Lambda, serverless compute service for executing code in response to events, suitable for lightweight tasks in distributed environments. API Gateway, managed service for creating, publishing, maintaining, and securing APIs, facilitating communication between distributed components. Horizontal scaling techniques, auto-scaling, automatically adding or removing instances based on predefined conditions or metrics, ensuring efficient resource utilization. Load balancing, distributing incoming traffic or tasks across multiple nodes or instances to prevent overloading and optimize performance. Stateless services, designing services that do not retain client state between requests, facilitating easy scaling and redundancy. Elastic load balancing, AWS service for automatically distributing incoming application or network traffic across multiple targets, improving fault tolerance and scalability. Benefits: scalability allows the system to handle increased workloads and user requests by adding more nodes or instances dynamically. Performance improves response times and throughput by distributing tasks across multiple nodes or instances in a distributed environment. Fault tolerance enhances system reliability and availability by distributing load and resources across horizontally scaled instances. Cost effectiveness optimizes resource usage and reduces operational costs by scaling resources based on demand. Flexibility supports rapid deployment and scaling of distributed components with minimal downtime and manual intervention. Tools and technologies. AWS ECS/EKS, orchestration services for managing and scaling containerized applications in distributed environments with operational simplicity. AWS auto-scaling, automated scaling feature for EC2 instances, ensuring optimal performance and cost efficiency based on workload metrics. Elastic load balancing, AWS service for distributing incoming traffic across multiple targets, improving fault tolerance and scalability. CloudFormation, infrastructure as code IaaC tool for provisioning and managing AWS resources, ensuring consistency in distributed deployments. AWS CLI, command line interface tool for efficient management and configuration of AWS resources and services in distributed setups. Challenges: configuration management, ensuring consistent configuration across horizontally scaled instances and services. Monitoring and scaling policies, establishing effective monitoring and scaling policies to respond to changing workload demands. Network complexity, managing communication and data flow between horizontally scaled instances in a distributed system. Security and compliance, implementing robust security measures and ensuring compliance with regulatory requirements in horizontally scaled environments. Performance optimization, Fine-tuning load balancing and scaling policies to achieve optimal performance and resource utilization.